Welcome to page 15 of your term combining packet. We know that when we subtract values, or in this case expressions, order matters. When it comes to addition, the order in which we add numbers or expressions does not. Let's take a closer look at what I'm talking about before we jump into the worksheet. If you're given the word problem, add 3 and 4, we know we can write it this way, 3 plus 4, and when we add, we get 7. But even if we change the order of the add-ins, 4 plus 3, the amount that we get, or the answer, is still the same, a sum of 7. The order in which we add doesn't really matter. The commutative property covers this rule. However, the property doesn't hold for subtraction. Let's take a look. If you are asked to subtract 10 and 6, you can write it this way, 10 minus 6, which of course equals 4. And that's correct. However, order matters because, as you know, if you reverse the order, 6 minus 10, the answer is not the same. It's actually negative 4. So, order is extremely important when you're subtracting. Let's take a look at a translation problem. When we're translating a problem, such as the ones you've been given, we go from word form to mathematical symbols. Let's take a look at the first one you've been given. It states 5 minus 3. As we translate that into mathematical symbols, we would certainly write it this way, 5 minus 3. We take the numbers in the order they are given from left to right. In the next one, 10 decreased by 4. Once again, since order is so important, we take the order of the numbers, 10 decreased by 4, and write them down in the order they are given. However, in our third problem, a little glitch occurs. It states, subtract 3 from 15. 3 must be deducted from 15. So even though the 3 comes first, as we translate, you actually bring the 15 up front and you are subtracting the 3 from it. This is called the from flip, where the 15 comes up front and the 3 goes in the back of the subtraction problem. It's a little glitch, translation glitch, that occurs as you go from word form into mathematical symbols. We're going to call it the from flip. That's important because, of course, when we do any subtraction, order is important. But it's important because we're going to apply the from flip to some of these problems that we've been given. Let's take a look at problem number 9. In problem number 9, it states, subtract 4x plus 5 from 9x plus 10. Well, as we translate into mathematical symbols, we're going to experience that slight translation glitch that occurs, and we're going to have to do the from flip. We are taking the 9x plus 10 and subtracting from it the 4x plus 5. Now that we've got it written as a subtraction problem, we're going to KCC, keep, change, change. The 9x plus 10 stays as is, but of course, subtraction becomes addition, and each term in the second quantity is going to flip to its opposite, negative 4x minus 5. Now that it's written as an addition problem, we can stack and combine. We take 9x plus 10 and negative 4x minus 5, and we combine our terms. When we combine this gain and loss, we get a gain of 5, and when we combine 9x and a loss of 4x's, we get 5x's. For this particular type of problem, there's actually 3 steps that you should show on your paper. Step 1, where you write the original subtraction problem. Step 2, the problem rewritten as an addition problem. And step 3, the stack and combine step off to the side. You're going to complete 10, 11, and 12 on your own. And you're going to make sure you complete the from flip in each of these as you write down step 1. Stop your video, complete 10, 11, and 12, just like we did for number 9, on your own. And when you're ready, turn your video back on. Complete those 3 problems. Please pause your video right now. Let's compare your answers to my answers. Make sure you have the 3-step process clearly laid out on your page. This is required every time you do a problem like these problems. You should have gotten for number 10, negative 4x minus 10. Give yourself a C. For number 11, 14x minus 1. And for number 12, you should have gotten negative 5x plus 17. Let's take a look at the last 2 problems on the page. Problem number 13 and problem number 14. Both of these are already written as subtraction problems. You do not need to do the from flip for these problems. Let's take a look. We can see that both of these problems are already written in subtraction form. We do not need to translate. However, we do need to KCC, or keep, change, change, and rewrite these problems as addition problems. The negative 3x minus 2 stays the same. However, we must change subtraction to addition and flip each term to its opposite. When we're ready to stack, we like to put the x terms up front and the constants behind. So as we stack these next 2 terms underneath, we bring the negative 5x up front and the loss of 9 under the constant of negative 2. At this point, go ahead and term combine, and then move on to problem number 14 on your own. When you're ready, turn the video back on and check the answer to problem 13 as well as the answer to problem 14. Please pause the video right now. You should have gotten the following answers. Negative 8x minus 11, give yourself a C, and 11x plus 5, give yourself a C. This concludes page 15 of your term combining packet.